So good evening to all. Really welcome today's participants to our innovative speech series. So once again, as a great evening to all. Innovative speech series, we are undergoing different type of topics under the series. So on that scenario, so today we are going to see next gen technologies. Today I welcome expertise from that panel, Mr. Rajarajan Manoharan. So belongs to Blooming Plant. Sorry for that. I think they're having some issue with him. So just please bear for a minute. Okay. Sorry, there is a technical issue. So I want to expertise Mr. Rajarajan Manoharan, so founder and CEO of Blooming Planet Lab. So welcome, sir. So I really hand over the today's session. So we hope you some motivated belongs to the new next generation convergence technology. So kindly proceed from your side, sir. So have a great session, sir. Thank you. So please remove your mute. Sir, please remove your mute. So I think you have a mute.
Yeah.
Now we proceed, sir. Yeah.
Green welcome all. Yeah.
So you have a presentation or any problem?
Yeah, presentation is yet to open, sir.
Yeah, fine, no problem.
Yeah.
Just proceed, sir. No issue. So otherwise, shall I start from my side or you are getting some issues there?
Sir, slide is not opening. Shall I start my presentation?
Yeah. So I will start from my side, sir. Let me start from my side.
Okay.
So I think we'll try.
Okay.
Can you proceed?
Okay. Shall we start?
Yeah. Sir, yeah.
Yeah. Okay. Green welcome all. This is Rajarajan for the Blooming Planet Labs. Today we are going to discuss about the upcoming technologies in the fourth industrial revolution, which is based on cyber physical protection systems. So, in the cyber physical protection systems, physical, digital, and the biological combinations of technologies are converged together. That is called as fusion technologies. That is also called as next generation convergence technologies. So, with this next generation convergence technologies, we are going to preserve the terrestrial ecosystems of our planet. Okay. So, our artificial intelligence, energy, and biosciences are the three faculties it has the potential to enable planet's infrastructure to the next level with the help of fusion technologies. But at the same time, it possesses some huge challenges also. What are all the challenges? See, climate change is the very big challenge as of now we are facing. So, how to overcome the problem of climate change crisis, world hunger, and excluding all types of pollutions? We have a solution. We have solutions in the with the help of upcoming technologies. So today we are going to discuss about the 3 topics which encompass the next generation convergence technologies and steering the 4th industrial revolution, which is based on cyber physical production systems. So 3 topics we are going to discuss. The first topic is self-sustainable multi-sensor platform for environmental monitoring. What is the reason to discuss about self-sustainable multi-sensor platform for environmental monitoring? Because we are in the verge of creating the smart cities. In the smart city, the sensor will be the omnipotent. That means having power overall and omnipresent also. So having the sensors omnipresent, we can't achieve the mission of a smart city. So the batteries, what are all the batteries we are going to utilize for that huge sensor platform should be self-sustainable. That means it should not reliable. It should not rely on batteries, because batteries are the prime source of non-biodegradable waste. So our huge sensor platform should be self-sustainable, should not rely on batteries. So how it is possible? Without battery, we can't recharge the electronic items. Then how it is possible to make the sensor platform self-sustainable? There is a possibility with the help of the triboelectricity. So triboelectricity will converge with nano generators. That is called as triboelectric nano generators. Okay. So that triboelectric nano generators will play the huge role in the making of self-sustainable multi-sensor platform. Okay. So before discussing the topic in detail, just give a glance to the key themes of Indian Smart Utility Week, which is going to of Indian Smart Utility Week, which is going to happen on March 2021, which is organized by Indian Smart Grid Forum. See, electric vehicle charging infrastructure, grid integrated vehicles, EV as virtual power plants, wireless charging of electric vehicles, smart energy communities. See, and the last but not least, digital twins. Digital twins holds a matter of great importance, because the multiple collection of internet protocol technologies are outpacing via the convergence of information technology as well as operations technology to connect people, process and technology to form the world of industrial Internet of Things, which can create the hyper-connected world. So, to create the hyper-connected world, This digital twin will play the major role. Digital twin is nothing but we can call digital twin also as the augmented reality. So, what are all the advantages of the digital twin? Say, for example, if we create the digital twin of any complex systems, so we can easily diagnose. We can easily diagnose a complex system. Say, for example, in the oil field, so huge systems will be used for drilling and exploration, all those purposes. There is a huge system will be used. That system nowadays they are applying the digital twins. So if we create the digital twins of the huge systems, automatically if any small dearrangement we can sense before it has gone worse. We can sense in the initial level itself. Okay. Okay. Now, see, these are also the key things of Indian Smart Digital Week 2021. So, all those things, see, the robotic process automation, paperless operation, contactless operation, digitalization, new services, revenue streams, chatbot, whiteboard, grid interactive buildings and campuses, all are pointing to 3 points. That is digitalization, decarbonization, and decentralization. So actually, the decarbonization should hold the third place, because with the effective digitalization to implement the decentralization can achieve the decarbonization. That is the 3D: digitalization, decentralization, and decarbonization. These 3 Ds, 3 distinctions we need to achieve or to preserve the 867 terrestrial ecoregions of our planet. So, how it is possible? How it is possible to achieve these 3 distinctions? List of technologies are coming. Okay. Say, for example, artificial intelligence, energy, and biosciences encompasses the diversified field technologies that we are going to discuss. Okay. If participants have any questions, you can ask. Any clarity you need from your side? Okay, we can go ahead. See, we have been discussing about the 4th industrial revolution. So that 4th industrial revolution will be taken care by the industry 4.0 or smart factory 4.0. So that is nothing but a digital transformation. So long back in the 16th century, the mechanical loom has been started. That is the first industrial revolution. Second one, current has been discovered. Then assembly line. Our great Henry Ford had discovered the assembly line, and productions has been started with the help of the assembly lines. Then Charles Babbage invented Then Charles Babbage invented computer. Then with that computer, all the advancement in the hardware and the software, and the software has been stored in the hardware. That the firmware setup has been advanced, and it has now. After that advancement, artificial intelligence, automation has been started. Automation has been started in the form of artificial intelligence. So, why nowadays artificial intelligence holds the matter of great importance means we are handling the huge data. Yeah, we are handling the huge data. So we need to rely on complex mathematical operations. That complex mathematical operations has been taken care by the AI framework. So that's why nowadays AI is gaining momentum. Okay. So now AI, energy, and biosciences. All three faculties holds the matter of great importance, because AI, to achieve AI, huge energy will be consumed. So to ameliorate the adverse effect of the huge energy consumption, we need to take care of energy also, along with the biosciences. So in this way, physical, digital, and the biological combinations of technologies are converged in the fourth industrial revolution, which is based on cyber physical protection systems, that is called as CPPS. See, look at the fourth one. We are here. Already we have discussed the multiple collection of internet protocol technologies are outpacing. We are the convergence of information technology and operations technology to connect people, process, and technologies to form the hyper-connected world we have discussed. So that is the progress of the fourth industrial revolution, which is mentioned here, fourth one. Okay. So now, what are all the softwares we have to handle? Digital twin can handle. So to create the infrastructure for the digital twin, we need to have a strong IoT framework, industrial Internet of Things framework. We need to rely on. So the strong industrial Internet of Things framework has been created by the General Electric. The name of the software is world's first industrial Internet of Things software. The name is Predix. Okay. Okay. If participants has any doubt or require any clarity in our discussion, just share the same in the chat window without any hesitation. Okay. Okay. So, as per our discussion, that self-sustainable multi-sensor platform. So, self-sustainable multi-sensor platform. Self-sustainable multi-sensor platform can be achieved with the help of the triboelectric nano generators, because self-sustainable sensor platform is the core component of Internet of Things and smart grid systems. So the Internet of Things is the base for smart grid systems. Smart grid is the base for smart city. So that's why the triboelectric nano generators will become the base for creation of self-sustainable multi-sensor platform. So this self-sustainable multi-sensor platform can be created with the advent of different kinds of triboelectric nano generators. Say for example, see, these are all the 4 fundamental modes of triboelectric generators. See, so triboelectricity has been derived from piezoelectricity. That triboelectricity can be generated by rubbing 2 different materials. So because of that, some stress and strain will be created that can generate electricity. That is the fine way to replace the batteries. Are you with me? So this is the main point, because how the trivoltaic nano generator can replace batteries. This is the procedure. So in the smart city, as we discussed, the sensors will be omnipresent and omnipotent. So in every structure is different. So as per the structural engineering of every framework, that sensor should be placed. So as per the possible stress and strain of the structures, this sensors will be recharged. So this is the procedure for making the sensors which is going to fit in different architecture layer of the smart cities without the help of batteries. Okay. Okay. Now, green energy generation. So self-sustainable multi-sensor platform is relying on triboelectric nano generators, but we need to generate the triboelectric nano generators in the large scale. Large scale triboelectric nano generators is the need of the hour. So as of now, the triboelectric nano generators are have created in the minimal output voltage range, as we see in this slide. See, the compatible sources are solar powered Internet of Things device scaled and solar PV cells, so and ambient radio frequency energies. So on a whole, what we are trying to create is we need the technological advancement. We need to create the smart city, but without disturbing our ecosystems. That is the main point, because the biogeochemical cycles, which has been taking care of our whole planet's energy budget. So we need to keep on improve our technological advancements by the handshaking with the every ecosystems. So that is the fine way to preserve our 867 terrestrial ecoregions of our planet. Okay. Okay. So see, single electrode based smart seed triboelectric nano generator. So this is one of the type of triboelectric nano generator. See, triboelectric nano generator are also called as TENG. So that is the suffix, and prefix will be changed as per the structure. So say for example, every day in our office, more than 8 hours we are keep on sitting and working. So in that case, we are producing some stress and strain to our cells. So that electricity, that seed can be turned as a smart seed with the base of single electrode. So that is single electrode based smart seed. So with the stress and strain, what we are giving to our seed, that can be converted, that mechanical energy can be converted into electrical energy with the help of single electrode based smart seed triboelectric nano generator. Okay, are you with me? Any doubts? Participants? Shall we go ahead?
Sir, we'll go. Sir, we'll go ahead, sir. So we will.
Yeah.
Hello?
Okay. Okay, we will continue. Yeah. Yes, sir. Shall we continue?
Sir, we will go with the last. So we will take the questionnaire session by last. Maybe they will only ask through only chat box only. So you just.
Okay. Okay, let it be. Okay, let it be. We can continue to discuss. Okay.
Yes.
Okay. Okay. This is the second one. Self-powered locomotion detector. So this locomotion detector has systematically studied and demonstrated to be a feasible power source that can commute operations of the LEDs. So self-powered locomotion, this C10. It is called as the self-powered locomotion detector for the security applications. It's also the wearable power source. So wearable electronics holds the matter of great importance in the implementation of smart cities, because our human body itself has the ability to create the electricity. So how we can make use of that electricity without affecting us in the greener manner? So that topic will comes under the bioelectromechanical autonomous nanosystems called as BEAMS. Okay, so later on we will discuss. Okay, the third one is green car. See, there is each and everything around us is knowledge, otherwise general knowledge. So likewise, every event, what are all the events are happening, are all triggered. It's making some friction. It's giving some stress. With that, they can generate the electricity. Say for example, there is a friction between the tire and the road. But so far we have been missing that energy. So with this single electrode triboelectric nano generators, we can utilize that friction and we can generate the electricity. It can improve the fuel efficiency. Otherwise, we can enhance the total mileage per charge of the electric vehicles. So, these green cars, they are really eco-friendly cars. So it will facilitate the battery charge also. Okay. So, but these single electrode triboelectric nano generators, we need to again, as we discussed, it should be come in the large scale manufacturing of triboelectric nano generators. As of now, it has been successfully deployed in the toy cars, but in the case of large scale triboelectric nano generators, the movement of electron caused by the friction that should be recreated in the larger manner in the framework of large scale manufacturing of triboelectric nano generators. Then only that will be applicable for the manufacturing of real cars. Okay. Okay. This is digital twin. So, as we discussed, we are in the fourth industrial revolution, which is based on cyber physical protection systems. So, in the case of the cyber physical protection systems, now we are in the pandemic days, right? So, we need to overcome from this situation. But at the same time, the production should be in the brisk pace. How it is possible? With the help of the cyber physical protection system that is possible. So what is mean by cyber physical protection systems? The physical protection should be happened with the help of the physical systems, but it should be tackled from the cyberspace. That is called as cyber physical protection systems. In the pandemic days, these cyber physical protection systems holds a matter of great importance. See the first one. This is the physical process. This is the digital twin of the same. So see, this is the 7-dimensional hologram. See, to create the exact digital twin of the complex physical process, we need to rely on 7-dimensional hologram. So that 7-dimensional hologram will help us to create the appropriate digital twin of the complex physical process. So, what is the necessity of creating the complex physical process? The necessity of creating the digital twin of the complex physical process is to diagnose the errors. Or faults occurred during the production in a timely manner. So that is the necessity. And you can see what are all the standards and security for data and connectivity. So it will include ERP, enterprise resource planning, manufacturing execution softwares, computer-aided design modules, sensor, pressure sensor, actuators, edge processing. What is the middleware we are using? Which middleware connects all the connects or converts all the IT and OT operations to connect people, process for creating the hyper-connected world and make the cyber physical protection system possible. All those things will be taken care by integration middleware. This integration middleware software holds the matter of great importance to make the cyber physical protection system happen. It will act as the effective and powerful middleware layer between the information technologies and the operations technologies. That means convergence of internet information technologies and operations technologies. What is the necessity to converge the technologies of information technologies and operations technologies? In the case of production should be happen with the help of the physical systems. That won't be changed. Production should be happened with the help of the physical systems. That won't be changed. But that will be monitored and handled from the cyberspace. That is called as cyber physical protection systems. So that's why the convergence of information technologies and operations technologies. These operations technologies encompass all the huge machinery items in the factories, which are going to be involved in Industry 4.0 or current factory scenarios also. So the sensors will play the pivot role. Will play the pivot role in the convergence of information technologies and operations technologies. In the case of the operations technologies, the active data of the huge machines has been collected from the sensors in that huge machines with the aid of operations technologies, and it will transmit that data to the information technology. So that is the necessity of the convergence of information and operations technologies. So that is the main thing we need to understand, because what is the necessity? Information technology is the operations technology is the, what is the necessity to converge the information technology and the operations technology? This is the need. Collecting the data, in and out data of the huge machine with the help of the digital twin. The help of the, once we have created the digital twin for the complex physical process, every movement we can, it will be reflected in the digital twin. So that digital twin will be straight away connected to the advanced sensors. So that sensors will share the data to the information technologies. In this way, the information technologies and operations technologies has been converged with the aid of multiple internet protocol connections technologies. So that's why we have discussed in the beginning itself. The multiple connection of internet protocol technologies, collection of internet protocol technologies are outpacing via the convergence of information technology and operations technology to connect people, process, and the technologies to form the hyper-connected world. So, with the help of this integration middleware. So this much of importance this middleware software holds. Okay. So then service buses, business analytic management software. So all those things, the name itself tells the meaning. It will give appropriate connections to between the middlewares and the existing systems. And data lake, data ingestion, everything will come under this operations technology. And the legacy data, see, legacy data, still we are trying to get the alternate for the legacy systems, but still legacy system exists. So we have not transformed, we have not transformed on a whole from the legacy systems. Still we are relying on legacy systems. So that's why this legacy data have been included. Okay, but every now and then we are transforming from legacy data. Okay. This artificial intelligence. See, as we discussed, why we are giving this much of importance to artificial intelligence? It has been evolved before 60 years. Why we are giving this much of importance to this artificial intelligence? Is this artificial intelligence because of our lifestyle? Because nowadays all the activities we are relying on digital transformations, whether it may be the ticket booking or our any business transaction or our private chats. It will include our webinar also. So everything data is the oil. So data is the oil for any kind of transformation. So that huge data handling, that mass amount of data can be tackled by the advanced mathematical operations like integral calculus, differential calculus, linear algebra, probability and statistics. So all those mathematical ability, eigenvalue, eigenvectors, all those mathematical ability is has formed machine learning algorithms. Machine learning algorithms is artificial intelligence is the subset of that machine learning. So that's why artificial intelligence nowadays is gaining momentum. Again, we need to have a strong understanding stating that artificial intelligence alone can't protect us. Artificial intelligence alone can't protect the ecosystem, terrestrial ecoregions of our planet. Artificial intelligence should converge with energy department and biosciences department. Then only we can preserve. Okay. So how we are going to preserve, we will discuss. So these cognitive engines. So these cognitive engines, cognitive computing. See, cognitive means everything is connected. So what are all the processes we have discussed, and what are all the systems have been involved? Everything is connected. Everything is connected with the aid of sensors. So that is called this cognitive engines. Is a quality of hybrid models. That's it. So all the complex operations of this convergence of information technology and operations technology will be notified, will be visualized in the dashboards. So every now and then, every nanosecond, all the activities will be monitored. Okay. So see, in this point of time, we need to. That's why we have discussed self-sustainable multi-sensor platform in our first phase. So because every now and then we need to monitor the huge data transaction with high security, but without affecting our ecosystems. So that is a challenge. So that's why we have discussed the self-sustainable multi-sensor platform in our first phase. Okay. Okay. Now, spintronics and quantum computing. So as of now, so far what we have discussed is how artificial intelligence is playing the main role in this fourth industrial revolution, which is based on cyber physical production systems we have discussed, and how the self-sustainable multi-sensor platform is playing the main role in the implementation of smart cities and smart factory 4.0 or industry 4.0. Everything we have discussed. So now it's a time zero. It's a time zero to discuss about the spintronics and the quantum computing. So what is the necessity? What is the necessity to discuss about the spintronics and the quantum computing? We can ask, right? So, see, the artificial intelligence, energy, and biosciences are having the potential to accelerate the evolution of exciting phase of our planet's infrastructure. Our planet infrastructure is evolving with the convergence of AI, energy, and biosciences. So, at the same time, our core objective is to maintain is to implement the digitalization. 3 distinctions we have discussed. Our core objective should be the implementation of digitalization in the decentralized manner. Implementation of digitalization in a decentralized manner. Then only we can achieve decarbonization. So all those technologies, upcoming technologies, with the help of the upcoming technologies, what we are struggling to achieve is decarbonization. Okay, so that is the main theme that will become the solution for the climate change crisis, because we are all relying on microbial ecology. We are all relying on microbial ecology or environmental microbiology. See, plants, animals, and microorganisms are all not relying on human, but we humans are relying on plants, animals, and microorganisms. These plants, animals, and microorganisms can be preserved only if we preserve the 867 terrestrial ecoregions of our planet with the help of the upcoming technologies. By attaining the core objective of implementing the digitalization in a decentralized manner to attain a decarbonization. So this is a very important thing we need to understand and dive deeper also, because there is no separate environmental science. Every faculty is directly belongs to environmental science. So this microbial ecology and environmental microbiology can be preserved. Can be preserved with the help of the in-depth knowledge of handling the atoms. So what are all the atoms? So the world is made up of atoms. Put it in simple. The whole world is made up of atoms. So what is the prime source of our existence in our planet? Water, air. So these are all the prime source we need. So that water molecule, how it has been formed. That water molecule has been formed with the two hydrogen atoms and one oxygen atom. So the electrons of the two hydrogen atoms and the oxygen atom have been covalently bonded with each other, and water molecule have been formed. So physics, chemistry, and biology all are interconnected. Physics, chemistry, biology. So physics is the base. With the base of physics, chemistry should be evolved. So that is called as physical chemistry. So with the application of the physical chemistry, biology, life has been started. So this is it. So in this way, this spintronics is nothing but a spin-on electronics. Spin-on electronics. See, these electrons, the subatomic particles. The subatomic particles are the invisible heroes, because these subatomic particles is the main reason. This is the main reason for the creation of water molecule. So that's why these subatomic particles like electrons and photons. Electrons and the photons. Both holds some equal priority, because the electron itself has a spin. So that spin of the electron, it creates some magnetic moment. That is magnetronics. So what is the necessity to scrutinize the movement of the electron and all those things? That is a question in our mind. It will come, because these quantum computers are based on quantum mechanics. This spin-on electronics is the base for quantum computing. How the spin-on electronics will lay the foundation for quantum computing? Yes. See, these quantum computers are all the applications of quantum mechanics. Quantum mechanics is nothing but a field of physics that studies the behavior of the object at the subatomic level. When the behavior of the object, how the subatomic particles are behaving when they are exposed to extremely cold. So that is quantum mechanics. So when the subatomic particles can behave in the extreme cold, will be different. Can form that behavior can form the quantum bits. That will be absolutely different from classical bits. See, you can see this block sphere. What is what it indicates? See, ordinary classical bits holds 0 or 1, negative electric signal or positive electric signal, 0 or 1. But this quantum bits will have the combinations of ones and zeros. These combinations of ones and zeros will happen in a femtoseconds, just more than enough nanoseconds. So in that nanoseconds, it will process huge data. So see, say for example, chemical reactions of ferredoxin. See, are you with me, people? Because see, this is important topic. If you have doubt in any point, you can immediately ask without any hesitation. Then only we can move away with this. So the point is quantum bits. Multiple quantum bits. We can gather multiple quantum bits called as quantum entanglement. So if the number of the quantum bits increases, the data processing will become higher. So by integrating the number of multiple number of qubits called as quantum entanglement possess huge challenge, because it should be in the extreme cold. It should be in a dilute refrigerator. So that's why IBM, Google, Microsoft, Honeywell, D-Wave, so all those huge vendors are keeping the quantum bits in the dilute refrigerator. And in the next 10 years, that means in the next decade, they are having the target of attaining the 1,000 plus quantum bits computer. So these quantum bits are very sensible. Even a gusty wind can make the quantum bit as an ordinary bit. So that's why it should be preserved in the dilute refrigerator. It should be in the extreme cold. So at the time of that the electron spin, at the time of attaining the both ones and zero, or any values became 0 and 1, that is called as superposition. So that superposition, superposition has the ability to store and to process the information in a faster manner, in a parallel manner also. We can ask the question, okay, already we are having supercomputers, then what is the necessity of having the quantum computers? Because in the case of the quantum computer, we need to preserve the quantum bits in a dilute refrigerator, and to have a huge processing, we need to keep the multiple qubits in a tandem. So the dilute refrigerator, we will need to place the huge dilute refrigerator. So like IBM, Google, and Microsoft, Honeywell, and DeWalt, like these huge vendors, rest of the upcoming vendors can't invest. So how it is possible to make the quantum computer commercial? So that is the research is going on. And the research is going on because quantum computing has the ability. Quantum computing has the ability to provide the solution right from the climate change up to the world hunger. It has the solution. How? Say for example, as of now, very big problem. As of now, very big, huge problem for our world is nitrous oxide. So, Haber-Bosch process is a process we have been relying more than 100 years. More than 100 years, this is a Haber-Bosch process we are relying on to make the nitrogen fertilizers. Is keep on depleting our ozone layer that allows the UV rays to penetrate in our atmosphere and create n number of diseases like corona and all. Okay, so that's why we are in the position to create the zero greenhouse gas emission nitrogen fertilizer. So for that, how we need to scrutinize how the nitrogen fixation will happen. So to scrutinize the process of the nitrogen fixation, we need to dive deeper into the chemical reaction of ferredoxin. That chemical reaction of ferredoxin can be calculated only with the help of quantum computers. It is not possible to calculate the chemical reaction of the ferredoxin with even advanced supercomputer, because it will exceed the age of our universe. It will exceed more than 13 billion years. It will exceed. So that's why Microsoft, IBM, and Google, Honeywell, DeWalt, Q Control from Australia, all those companies has joined-handed to simulate the nature. So to simulate the nature, they have started from creating the zero greenhouse gas emission nitrogen fertilizer. Okay, so like that, n number of challenges. Say for example, carbon capture technologies and material sciences, nitrogen fixation technologies, all those things are evolving on with the help of machine learning. So, two things: carbon capture technologies and nitrogen fixation technologies. All those things should be happen in the natural manner, but as per the current scenario, we need to simulate as per the advent of current fourth industrial revolution, which is based on cyber physical production system. We need to recreate the carbon capture technologies and the nitrogen fixation technologies and advanced material sensors concept, which can keep the coherence level of quantum bits for a longer time to make the quantum computer to create the commercial based quantum computer for finding the solution of climate change crisis, world hunger, and another potential problems what all we have. Okay. So this one is the spintronics generator. So spintronics, we have discussed spin-on electronics. What do we have discussed is spin-on electronics, and that because of the intrinsic spin of the electron, which can cause the magnetic moment, we can create the electricity with that quantum effects within the layered materials, convert natural and ever-present ambient sources of energy into electrical power. So this is the one of the application of spintronics. So this spintronics generator has been, creation of the spintronics generator has been in progress. So has been in progress. We need to meet with some technical challenges. So on a whole, in the last 1 hour, what we have discussed is about the overview of dark technologies. Dark technologies is nothing but distributed ledger technologies and artificial intelligence, extended reality, and quantum computing. So what are all the technologies we have discussed in our discussion? So they come under this DARQ technologies. So the researchers, entrepreneurs, students, and everybody from the diversified field are cordially invited to encompass the diversified field technologies to preserve our 867 terrestrial ecoregions of our planet, to avoid or foil the 6th mass extinction with the help of the next generation convergence technologies. So Blooming Blue Planet Labs cordially welcomes all for the same. Thanks for your attention. Now participants can ask questions.
So thanks for your expertise session, sir. I think we didn't receive any question in the chat feed. So I really thank for your wonderful session based on that. So new generation and convergence. We will have a brief session on the upcoming time. So I thank really for your interest, and so we will have one conversation. Then I really thank the participants for the more than we crossed more than 1 hour. So I really thank once again to the participants. So we will meet in the other upcoming series. So thank you for meeting us.
Yeah.
So
good day.
Yeah.